Welcome to Physics with Sanmitra. I am Sanmitra Bhaumik and today there will be a problem session on kinematics. The level of the session will be level 1, that is of the NEET level or the JEE mains level, and also we will be having level 2 and level 3 also, where level 2 is of the tougher problems asked in JEE mains and JEE advanced level, and the level 3 will be of the tougher problems asked in JEE advanced and Olympiad level. Okay, so without wasting any time, let's begin. We have already given you the problem sheet, and I am getting a good response, that is the students are solving the problems themselves. But then also I am solving the problem for you in this video so that you can match your method with my method and you can go for the appropriate one. Okay. First question. The coordinates of a moving particle. The coordinates of a moving particle at any time t are given by x is equal to at cube and y is equal to bt cube. Sorry, alpha t cube and y is equal to beta t cube. This is alpha. So now speed of the particle is given by 3t alpha square plus beta square root over of 3t square root over of alpha square plus beta square t square root over of alpha square plus beta square root over of alpha square plus beta square. Okay. Now we are asked to find the speed. See, this x, it is varying with time, y is varying with time. So we can find the vx and vy, the velocity of the particle, the x and y component, by differentiating it dx by dt and dy by dt. And what will be dx by dt? Dx by dt will be 3 alpha t square. 3 alpha t square. Dy by dt will be 3 beta t square. And if we perform the vector addition, that is vx square plus vy square, then if we perform the vector addition, we will get option B. See, I have solved it also. Vx square plus vy square and root over of 3 alpha t square whole square plus 3 beta t square whole square. This 3t square will take out common, root over of alpha square plus beta square. Done. So this was a fairly simple problem, and let's move on to the next problem. A stone is dropped into a well in which the level of water is h below the top of the well. If v is the velocity of the sound, then time t after which the splash is heard is given by. First one is 2h by v, second one is root over of 2h by g plus h by v, third one is root over of 2h by v plus h by g, fourth one is root over of 2h by h by 2g plus 2h by v. Now let's see what happens here. Number one thing, let's understand the problem. See, there is a well and a stone is dropped into the well. What do you mean by the word drop? That means the initial velocity is 0. Now when the initial velocity is 0 and the height is h, to find out the time I can write h is equal to half gt square. So t is equal to root over of 2h by g. It takes t time to fall, and the splash, here is water, let's say. This splash takes, the sound takes time, say t2, t dash, to reach the top of the well. So I can say the total time is t plus t dash. That is the time after which he will hear the splash. First the stone has to reach the ground, reach the water, and the sound has to reach the person. So what is t? T is root over of 2h by g. And what is t dash? T dash is very simple, h by vs, that is the distance, height by vs. Vs is the velocity of sound. So that is our answer, and our answer is option B. Let's move to the third question. A stone freely falls under gravity. It covers distances h1, h2 and h3 in intervals of 5 seconds respectively. Relation between h1, h2 and h3 is option A, h1 is equal to h2 by 3 is equal to h3 by 5. Option B, h2 is equal to 3h1, h3 is equal to 3h2. Option C, h1 is equal to h2 is equal to h3. And option 4, the option D, h1 is equal to 2h2 is equal to 3h3. So let's understand what this question actually means. Some of the students had confusion in the meaning. The meaning is exactly the complete here. The question has nothing wrong in it. See, I am dropping a stone. The stone is dropping downwards. in the first 5 seconds, see, what do you mean by intervals of 5 seconds? In the first 5 seconds, it will cover a displacement of h1. See, first 5 seconds. In the next 5 seconds, that means 5 seconds to 10 seconds, it will cover a displacement of how much? Say it is 10 seconds. It will cover a displacement of h2. In the last 5 seconds, the third 5 seconds, that is 10 to 15, I can say 10 to 15, it will cover a displacement of h3. Now it is now the stone is freely falling, so I can say one thing, that h1, h is proportional to t square, because h is equal to half gt square. H as a function of time, that is proportional to t square, so I can say ht by t square, that is constant. Now I can say one thing. See, h1, what is h1? The displacement of the stone from 0 second to 5 seconds, so that is 5 h5 minus h0, that will be proportional to 5 square minus 0 square. What is h2? The displacement from between 5 to 10 seconds, so h10 minus h5, that is proportional to 10 square minus 5 square. What is h3? h3 is between 10 to 15, so h15 minus h10, so that will be proportional to 15 square minus 10 square. I think this much is clear. Since h is proportional to t square, ht, and so we are just replacing this proportionality constant. Now what we can do here is that, let's look at the solution now. I have done this till this much. Now h1 by 5 square is equal to h2 by 10 square minus 5 square is equal to h3 by 15 square minus 10 square. So just h by t is constant, so I have just that is equal to that k what we told, that is equal to k. I have not written here. So h1 by 1, see, 10 square minus 5 square, what is that? 75. 5 square is 25, and so on. I can say h1 by 1 is h2 by 2, h2 by 3 is equal to h3 by 5. This is actually a standard result, and I can write that h1 is to h2 is to h3. If the stones are, that is h4, that is I can write 1 is to 3 is to 5 is to 7, and it will go on. So in case of equal intervals, if I were to calculate the distance, then we have to find like this. So correct option is option A. h1 by 1 is equal to h2 by 3 is equal to h3 by 5. We can also directly mark the answer. Okay. Now a particle covers half of its. See, there is a slight mistake in this question. I had already updated that in the revised one. I could not update it here. Okay. Now read the question. Now it's correct. A particle covers half of its total distance with speed v1 and rest half distance with speed v2. Its average speed during the complete journey is. Now this is a fairly simple question, but such a questions are also asked. So this is the first problem sheet level 1, so I have given it here. See, let the total distance be 2x. Now this first half for x, it is taking a time t1, and second half of x, it is taking a time t2. So what will be t1? T1 will be x by v1. What will be t2? T2 will be x by v2. So what is the average velocity or average speed? That is average speed. Average speed is total distance, that is 2x, by total time. Total time is t1, that is x by v1, plus t2, that is x by v2. So we can write here x and x will cancel, it will go up. So 2v1 v2 by v1 plus v2. So our correct option is option C. Here we have to be careful that we have to calculate the total velocity. So total displacement by total time, total average speed, so total distance by total time. So that is the thing. It is not that difficult. Next, Displacement of a particle varies as x is equal to a e to the power minus alpha t plus b e to the power beta t, where a, b, alpha, beta are positive constants. Velocity of the particle will be option A, independent of beta, option B, drop to 0 when alpha is equal to beta, option C, go on increasing with time, option D, go on decreasing with time, option C, option D is go on increasing with time. Now let's look at the solution. See, we have been given the displacement as a function of time. Now what we have to find? We have to find the velocity as a function of time. So I have to do v, that is dx by dt. What will be dx by dt? Let's find out here. V is equal to dx by dt. It was a e to the power minus alpha t. So minus alpha a e to the power minus alpha t plus beta b e to the power beta t. This is our velocity v as a function of t. Now let's look at, there was an option which stated that if alpha is equal to beta, then both will be 0. The velocity will drop to 0. Alpha is equal to beta, velocity will drop to 0, but that is not true. You just put alpha is equal to beta, but there is a to the power minus alpha t plus b. So alpha is equal to beta will not necessarily put this term to 0, because here it is minus alpha and plus beta, and also a and b are not equal to alpha and beta, so that is not correct. Now the thing is that there are two options. One is it will be increasing with time or it will be decreasing with time. Let's see. Let's look at the components individually. This part 1 and this component. See, this component, see, b and beta both are positive, and e to the power beta t is also positive. And also when I'm in, see, e to the power beta t, how the curve will appear like this. It will appear like this. Let me draw the curve properly. This is a very good question at NEET level. See, what will be e to the power beta t? Say at t is equal to 0, this will be beta into b, and it will be increasing like this. Okay. Now what will be about minus alpha a e to the power minus 8 alpha t? See, e to the power minus alpha t, the curve will be like this. It will be decreasing. At 0 it will be 1, and at t tends to infinity it will go on decreasing. But there is a minus sign multiplied to it, so it will start from negative here. It will start from negative like this. And again the magnitude is alpha into a, and alpha and a both are positive, so minus alpha a will be negative. So it will be something like this, minus alpha a. So this is also an increasing function and this is also an increasing function. So two increasing functions will add up to give an increasing function, say something like this. It will give, but it will be increasing. So velocity will go on increasing with time. So our correct option is option D. So that's all for this video, and the next questions will be solving in the next video. And if you like our channel, please subscribe to our channel, and please share this video with your friends, and thank you.